Good morning, everyone. Happy Friday. Welcome to TVE Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, Viridiana Fernandez, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. This session will provide Tejano passport points, and the code will be posted on the chat towards the end of the session. So now, at this time, please mute your mics for the best sound experience. Otherwise, the feedback could interfere with the information we will be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. Without further ado, I'll pass it on to Ms. Fernandez so that we may begin.
Hi, good morning, everyone. I'm here to cover for Ms. Chuka. And today we will be covering finding zeros of a polynomial function. If at any time you have any questions, please raise your hand and then I'll be more than happy to stop and explain any doubts that you have. Okay, so finding zeros of polynomial functions is section 2.5. This is the first way to find zeros of a polynomial function. If we are given a graph, any place where my graph intercepts the x-axis is going to be a 0. So for example, on the first graph, if we see my graph is crossing the x-axis at -1, at -2, and at 4. So my polynomial in factor form is going to be f of x equals x minus 2, x plus 1, and x minus 4. And my zeros are 2, -1, and 4. And again, those are the places where the graph is crossing the x-axis. And then for the second one, we have the same situation. We are going to have two zeros, -2 and 2. That's where my graph is crossing the x-axis. And then for the third one, we have -2, 0, and 2. Now, if you notice, for example, 0 over here, it repeats twice. Do I have like a pointer? I do, right? Here, okay. Yeah, so we have this x equals 0 and x equals 0. That means that it's a multiplicity of 2. And then my graph is only gonna touch at the 0. It's not gonna actually cross it like it does in -2 and at 2. Now we have the fundamental theorem of algebra. So if f of x is a polynomial of degree n, where n is greater than 0, then the function has at least one 0 in the complex number system. So the degree of the polynomial is going to tell us exactly how many zeros it has. So for example, here it says determine the number of zeros of the polynomial functions below. Oh, it's moved. So for the first one, we are going to see that this one is x cubed plus 3x squared plus 2. So the first thing we need to check is that it's written in descending order. So from greatest to least. Now this one, the first one is, so it's my highest exponent is 3. That means that my function is going to have 3 zeros. And then for the second one, this one is x to the 4th minus x to the 6th. We are going to rewrite it, and we're going to write negative x to the 6th power plus x to the 4th. And this one is going to have 6 zeros. And I think that's the next slide. So this is what I just said. So the degree is 3, therefore there will be 3 zeros. And then for the next one, the degree is 6, so there will be 6 zeros. And remember, sometimes the zeros, they can repeat, and that's a conversation to talk about multiplicity. That is gonna tell us if my graph crosses or touches at that 0. Okay. So for this one, it says find the zeros of each polynomial function. I'm not sure why it's not. Okay. So the first one is x minus 2. For that one, we can do different things to find zeros. One is to graph it, or to factor, or sometimes it might be factor like the last one that we have. And if it's a quadratic function, we can also use the quadratic equation to find the zeros. So in the next example, this one is the one that says f of x equals x minus 2. And this is a line, so this one is graphed, and it crosses the x-axis at 2. So that's why that one is going to be a 0. And then to solve for it, we say x minus 2 equals 0. We add 2 on both sides, and then that's going to be my 0. Give me 1 second so I can get my pen to write here. Okay. Does it let me? Yeah, so you do x minus 2 equals 0, and then add 2 on both sides, so x equals to 2. And then if you notice, this polynomial is to the first degree, so we only have 1 0. And then for the second one is an x squared, and this one is going to be a parabola. So one of the things we can do is factor, or we can do the quadratic function. So this one, they factor it. So we have 0 equals x squared minus 6x plus 9. So two numbers that when I multiply them give me positive 9, and when I add them give me negative 6. This one should be a 3. And then we make those two equal to 0. So x minus 3 equal to 0, and x minus 3 equal to 0. So both of these are going to be x equals to 3. And if you notice, they repeat. So that means that their multiplicity is 2, which is even. And when we have that situation, my graph only touches the x-axis. And we can see here that it is not actually crossing, it's just touching it. And then the next example, this one is already factored for us. So we are going to solve for each one. So we make each one equal to 0. So x equals 0, x minus 2i equal to 0, and x plus 2i equal to 0. And then when we solve for them, we can see that we have two zeros that are not in the real numbers. They are part of our imaginary numbers, which is section 2.4. And then we have x equals 0, and we can see that it's crossing the x-axis at 0. Okay, so another way to find a 0 of a polynomial function is when they give us 1 0. So in this example, they're giving us a 0, which is x equals to 4. What we're going to do when we have this situation, we're going to do a synthetic division. Okay, so again, since x equals 4 is a 0, we can use the synthetic division to find the rest of the zeros. And then, so, I don't know why it's like that. So when we do the synthetic division, we say 4, and then we write the coefficients of our polynomial. But for the coefficients, if you notice on my original polynomial over here, there is no x squared. When we have a missing power, we replace with a 0. So that's why here we have a 0. So we have 1, which is my coefficient of x cubed, and then a 0, because x squared is a missing power, negative 13, and negative 12. So the synthetic division, we bring the first one down and then we multiply. 4 times 1, 4. And then we add the column, 0 plus 4, 4. And then we multiply again. 4 times 4, 16. And then we also add the column. So negative 13 plus 16 is positive 3. And then we multiply again. 4 times 3 is negative 12. It's positive 12. When we add these two, that's going to give me 0. So from this one, we're going to find our quotient. And then our quotient, we're going to either factor it or use a quadratic equation to find the other zeros. Mhm. So this part right here, this one right here, that's my quotient. So my quotient is x squared plus 4x plus 3. And this one is factored. We can factor it. So two numbers that when we multiply it give me positive 3, and when we add them give me positive 4. So 3 times 1 is 3, and 3 plus 1 is 4. And then to solve, we make each one equal to 0. Subtract 3 from both sides. That gives me negative 3, and subtract 1 from both sides. So the other zeros for this polynomial function are going to be x minus 3 and x minus 1, and x equals 4 is the one that they gave us at the beginning. Okay, so we have this one, and now we have this example that says find the zeros of the polynomial function. Now, what is the difference between this example and the example before? The main difference is that in this one, they did not give me a 0. So we are going to have to find the zeros. Okay, so one thing we could do is to start guessing what zeros will be for this polynomial function. So let's say, for example, we can take 0 and then try it out, and then if it works, then that's going to be a 0. But we're going to find a new method to find the actual zeros. And that's going to take me to the possible rational zero test. Give me 1 second, guys. Okay, so to find the possible rational zeros, we have the rational zero test. And to use it, we're going to list all the rational numbers from the numerator and the denominator. So again, factors of the constant term over the factors of the leading coefficient. So remember, we always have to write our polynomial in descending order. And the x that has the highest degree is going to be our leading degree. And that one's going to be our leading coefficient. What is a factor? So for example, 8. 1 times 8 gives me 8. Those are factors of 8. And also 2 times 4 is 8. And those two are factors of number 8. And then we have an example for 24. So 1 times 24 equals 24. 2 times 12 equals 24. 3 times 8 equals 24. And 4 times 6 equals 24. These are all factors of 24. So find the rational zeros of the polynomial function and using the rational zero test. So what is a constant term factors and what is a leading coefficient factors? So in this one is minus 9. So negative 9 is our constant and our leading coefficient is 1 because this x cubed has a 1 in the front. So to find the possible rational zeros, we're going to write down the factors of 9 over the factors of the leading coefficient. So the factors of 9 are 1, 3, and 9. So 1, 3, and 9. 1, 3, and 9. And my leading coefficient, the factors is only 1, okay? And we're going to do a plus and minus for both of them. I think I have it on the next slide. So let me write it here. So we said that the factors for 9 are 1, 3, and 9. And the factors of the leading coefficient are 1. So we divide. We take 1 divided by 1 is 1. 3 divided by 1 is 3. And then 9 divided by 1 is 9. So we should have the 9 here too. That's another possible 0. So 1, 3, and 9. Okay. Now to test them, we're going to do what we did before when we had the example with the x equals 4. We're going to take one of those zeros. It doesn't matter which one you start with, but I always recommend starting with 1 and with -1. So we're going to use the synthetic division again to test the possible ones that we have found. So here we're going to test number 1. So same process. Write the coefficients of your polynomial. So that's why we have 1, 1, -9, and -9. And then 1 is the 0 that we were testing. So when we have synthetic division, bring the first one down, and then we multiply. 1 times 1 is 1, and then we add 1 plus 1 is 2. And then we multiply 1 times 2 is 2, and then we add them. -9 plus 2 is -7. And then again, 1 times -7, -7, and then we add the column, that gives me -16. So from here, we can see that this one is not going to be a 0 because we have a remainder of -16. So 1 is not a 0 for this polynomial function. So we're going to try another one. Now we're going to try -1. So for -1, we do the same steps. So bring the first one down, 1, and then we multiply. -1 times 1 is because this is moved. So I'm going to do it here. So bring the first one down. So this is 1. 1 times 1 is 1 times -1 is -1. And then we add these columns, 1 minus 1, 0. And then -1 times 0 is 0. -9 plus 0 is -9. And then we multiply. -1 times -9 is, and then we multiply. -1 times -9 is +9. And -9 plus 9 gives me 0. So this one will be a 0 because we have a remainder of 0. Okay, so now we have found 1, which is -1. And then from here, I have my quotient, which my quotient is going to be x squared minus 9. And then we have two options again. We can either factor or we can use the quadratic formula. This is the synthetic division. So here's what I'm talking about. This is my quotient from the synthetic division. Let me do it here because they do it differently. So then we have three options. We can factor, we can use the square root property, or we can use the quadratic equation. So here we're using the square root property. So what's going on here? We have x squared minus 9 equal to 0. We add 9 on both sides. So we have x squared equals to 9. And then we take the square root on both sides. So remember, when we take the square root, we have a plus or minus. So this is x equals plus or minus. 9 has a square root, which is 3. So now we know all of our zeros. The first one was -1, +3, and -3. Okay, this is what I was showing you right now. So we have our zeros again, -1, -3, and +3. And then the factors for this polynomial are as follow. So we do the opposite. So my 0 is x equals -1, then my factor will be x plus 1. If my 0 is x equals -3, then my factor is going to be x plus 3. And then if my 0 is x equals to 3, then my factor is going to be x minus 3. Okay, so this one is another example. So find the rational zeros of the polynomial function. Enter answers with a comma. And if it doesn't exist, we're going to write DNE, which is what WebAssign will ask. Okay, so we need to write the factors of the leading coefficient. So the leading coefficient is 2 in this case. And then my constant is going to be 1. So it's the factors of the constant over the factors of the leading coefficient. So let me just rewrite this. So we have plus or minus 1 over plus or minus 1 and plus or minus 2. So my possible rational zeros are 1 and 1/2, negative and positive. So we're going to do the same thing. We're going to check if these are zeros of the function. So to check, we take one of them and then we test it. So for example, here we're going to test number 1. Okay. So when we do the synthetic division, we can see that we have a remainder of 4. So then positive 1 is not a 0. Now we can use -1. And this one will work because if you see, we have a remainder of 0. Let me see. Gemma, do you know why the PowerPoint is moved? Because mine is not moved like that.
It might be because it's in PowerPoint itself. If you want to try to upload it as a PDF, that might work.
Okay, let me try that because it's all moved.
Yeah, it's
So
shifted. Yeah, go ahead, take your time.
thank you.
Thank you. Here, what I'm going to do is I am going to download this presentation and then I'm going to try to upload it on my side. When
Okay.
I download it, it downloads as a PDF.
Oh, okay. Thank you so
We'll
much.
see. Of course. So you're on slide 54. Okay.
Yes.
Let me
Thank
go
you.
ahead. It's converting. Let me go to that slide and hopefully
It
it's
works.
okay. We'll see how it is.
Yes, thank you.
Of course. You know what, Ms. Fernandez? Because I downloaded it straight from Blackboard,
Hmm.
um, it shows me the exact same thing.
Yeah, so I don't know. I'm sorry, everyone. I'm not sure. And it doesn't let me save it. It doesn't even give me the option to save it as a PDF.
Mm-hmm.
Mm,
Let me see.
let me see.
Yeah, because on my side, if I download it from my side, it's just the exact same thing. So it doesn't show me the original version of it.
Okay, let me see. I think I was able to do it. Mm, so let me upload it here. Downloads. No, it's not showing. Because it tells me, well, let me see. No, it's still a PowerPoint.
Mm-hmm. Yeah, it might. If she has it password protected, yeah, then there might not be a way to try to shift it.
Yeah, because that's what it says to me. It says that it's password protected.
Yeah, yeah. So I mean, I don't know if you want to, keep going with the slides with what is like a little easier to understand. Um, and then if students have specific questions, about, for example, this one, right? That is the screen is a little funky. um,
Yes.
get them to do. So that way they can also get that help there.
Okay. Well, yeah, let's go ahead and do that.
Okay,
Okay. So thank you so much for your help.
of course, of course, of course.
Okay, so here we have another polynomial, and then we checked another zero, which is -1, and then here we have a remainder of 0. So then that means that -1, it is a 0. And then we have our quotient, which is 2x squared plus x minus 1. And then again, we have any options to solve this. We have the quadratic formula, or we can factor it. So this one is going to factor, and it factors to 2x minus 1 and x plus 1 equal to 0. Okay. And then we solve each one. So we say 2x plus minus 1 equal to 0. And then we solve for x. So we add 1 on both sides. So we have x equals 2x equals to 1. And then divide both sides by 2. So x equals to 1/2. And then the other one is x plus 1 equal to 0. We subtract 1, so x equals 2. -1. And that what I showed right now is what is happening on these slides. And this one shows nice. So again, we did the synthetic division with -1, and then we have a remainder of 0. And then we factor the quotient, which is this part right here. So we found also that we have x equals 1/2 and x equals -1. So that x equals to -1, it repeats, so it has a multiplicity of 2, which is even, which means that it's not going to cross. This one is only going to touch at -1, and it's going to cross at 1/2. Okay. And this next slide mentions what I just said. All right, so for this one, we have another example. So find the rational zeros of the polynomial function. So we have two ways to solve this. So one, of course, is to use the rational zero test, but if you notice, my function doesn't have any constant. So my possible zeros are 0 over +1. So the only possible rational zeros is going to be 0, because remember, when we have 0 divided by a number, it's always 0. Okay. And then it says we're going to use a synthetic division. So let me find the slide that has it nice again. So for the synthetic division, we're going to repeat the process. Okay, so we have 0, and then we have a new quotient, and then we're going to repeat the process with this new quotient. So remember these zeros that we have here? These right here are because there are missing powers in our original one. So the original was t to the -6 power in our original one. So the original was t to the -6 power plus t squared. Okay. So this is just repeating the process, and then until we got to this point, which is -t to the 4th power plus 1 equal to 0, and then we can factor it. Okay, so that one's going to factor to these two, and then we're gonna make those equal to 0. Right here, equal to 0, equal to 0, and then we're going to solve for that t. Okay, and when we do that, it gives us that t equals to plus or minus I, and t equals to plus or minus 1. Now again, we use the synthetic division with 0 because that was the only possible 0 that we found. And then when we found a quotient, we repeat the process with the quotient. And then we have another quotient, which is -t to the 4th power plus 1. And that's the one that we factored right here. Okay, so that one's factored here. And then my zeros for this function, remember, if this is a polynomial of degree 6, it means that we are going to have 6 zeros. And we have here 1, 2, 3, 4, 5, 6. And these are all my zeros. So the 0 has a multiplicity of 2. And then we have 1, -1, I, and -I. And here's my graph for that function. So it crosses the x-axis at -1 and at 1, and it touches at 0. because this one have a multiplicity of 2, which is even. And when my multiplicity is even, it only touches, it doesn't cross. Okay, I'm gonna skip the other part because it looked really crazy. So for this one, it says find the rational zeros of the polynomial function. So we have, again, the rational zero test, which is the factors of the constant term over the factors of the leading coefficient. So the factors of my constant here are 1, 2, 3, 4, 6, 8, 12, and 24. Remember, my constant is a number that doesn't have a variable with it. And then my leading coefficient is 9 because x to the cubic is my highest degree. Okay, so this one is just writing these factors over the factors of the leading coefficient. And remember, we always have to have a plus or minus. So we have all these possible zeros. We have 1, 2, 3, 4, 6, 8. And then we also have 1/2, 1/4, 1/8. Let me see if it shows here. So when we have our list of the possible rational zeros, we're going to do the same thing. We're going to choose one and we're going to test it in the original polynomial. So this is my original polynomial and we're going to test and then we're going to test number one. Sorry guys. Okay, so we do the synthetic division, and if we see here 30, we have a remainder of 30, which means that this is not a zero. We need to have a zero there in order for the number to be a zero. So we're going to check for another possible rational zero. Here we're going to test number 2. So when we do our synthetic division, we can see that we have a remainder of 0. So that means that 2 is a zero of this polynomial. But we want to find all 4. Because remember, this is a polynomial to degree 4. That means that I'm going to have 4 zeros. Okay. So this is my new quotient. What can I do next? So we're going to repeat the process with the new quotient. So now with the new quotient, we're going to find again the possible zeros for this one. So these are my possible zeros. So the factors of the constant term, which in this case is 12, and then the factors of the leading coefficient, which is 9. And then all these are my possible zeros. All this. So you choose one and then you test it out. Sorry. Okay, so let's see number 3. So 3, we do the synthetic division. And then if we see here, we have a remainder of 0. So 3 is a zero of the polynomial. And then we have another quotient, which is 9x squared minus 4. And we're going to repeat the process, or this one is already x to the second power. This is already x to the second power, so we have different methods to solve quadratic equations. So this one, we can use the square root property. Okay, so to solve for x, add 4 on both sides, and then divide by 9. and then we take the square root on both sides. And then remember, when we take a square root, we have a plus or minus here. And then x equals 2 over 3. Okay, so this is everything together. Okay, so we did the first synthetic division with -2, which was a 0, and then we repeat the process with the quotient, and then the last quotient, which is an x squared, which is usually what we want to get to an x squared, we have different options. So here we did it using the square root property. So over here I have all of my zeros. Okay. Now, this one, the factors are x plus 2, x minus 3, x minus 2/3, and x plus 2/3. Okay, now we have another example. So consider the following. So x to third power plus x squared minus 9x minus 9. So list all the possible zeros of f. So to list all the possible zeros, again, we do the test. So we write the factors of the constant term over the factors of the leading coefficient. Okay. So here my possible rational zeros are plus 1, 3, and 9. So to find the zeros, we test one of the zeros that we found using the rational zero test. So we have plus or minus 1, plus or minus 3, and plus or minus 9. So again, always I would say try 1 and -1 as your first zeros to try. So here we are going to do number 1. So if you see here, that one gives me a remainder of 0. Okay, and we actually did this example earlier. So then we have x squared minus 9 equals 0, x squared equals 9. Take the square root on both sides, and then we have plus or minus, and the square root of 9 is 3. So my zeros are -1, -3, and 3. And my factors is the opposite. So x plus 1, x plus 3, and x minus 3. Okay, now we are going to, with the same one, we're going to find the graph for this one. So if you remember from a section earlier, to find the leading coefficient test, we need to see if my leading coefficient is positive or negative, and if the degree of my function is odd or even. And that's going to tell me the behavior of my graph. So for this one, my coefficient, my leading coefficient is 1, and my degree is 3. So then we have a positive and odd function, which means that it's going to rise to the right and fall to the left. Okay, so again, this one was positive and odd. So odd because my power is 3, that's odd, and my leading coefficient here is positive 1. Okay. And then the zeros and the multiplicity is what I was talking about earlier. So if a zero has a multiplicity that is even, it's going to touch the graph. And if it has a multiplicity that is odd, it's going to cross the graph. So in this example, my zeros were -3, -1, and 3. So that means that my graph, all these are odd. This is only 1, only 1, only 1. So the multiplicity is odd. Okay. And then to graph this, we have all the information we need. We know the zeros. We can find the y-intercept, and to find the y-intercept, we're going to substitute with 0 wherever we have x. Okay, and then we're going to choose additional points. So to choose additional points, you create a table and you choose values for x, whichever values you want to choose. Okay, so this is a sketch of the graph. So these are my zeros, -3, -1, and +3. That's the first thing we're gonna do. And then we're going to draw the end behavior that we found. Again, this one falls to the left and rises to the right because my leading coefficient was positive and my degree was 3, which is odd. Okay, and then the additional points are these examples that are here. So the additional points that were chosen here are -2, 1, and 2. So the other points that we're going to graph are -2, 15, 1, -16, and 2, -15. And those are these 3 red dots that you see here on the graph. And then this green one right here is my y-intercept. Okay, and then we connect everything. And this is the graph for that one. Okay, here it is nicer, but we cannot see the y-intercept, but we can see here that it's crossing in my zeros because they had a multiplicity that it was odd. Okay, now the last part of 2.5 is to find a polynomial function with real coefficients that has the given zeros. So here they're giving you 2 zeros, 3 and -4. But when we have, a -4i. When we have -4i, the complex conjugate of this one is also going to be a 0. So that means that the other 0 of this function is going to be +4i. So this polynomial function has 3 zeros. That means that it's going to be to the 3rd degree. Okay. So this is what I just said right now. So again, when they give you this, the complex conjugate of it is also going to be a 0. So my zeros for this one are x equals 3, x equals -4i, and x equals +4i. So therefore, this one is going to be a polynomial of degree 3. Then we're going to list the factors. Okay. So if these are my zeros, this right here, then my factors are x minus 3, x plus 4i, and x minus 4i. Okay. To find the polynomial, what we're going to do next is to multiply all these 3 factors. Now this an right here is because we don't know our coefficient yet. Okay. So again, I said we're going to multiply all the factors together to find the polynomial. Now you have different options to multiply this. You can multiply the first 2 parentheses, but here we're going to multiply the last 2 first, and then at the end we're going to multiply with x minus 3. So we're going to FOIL, distribute. Okay, so this is where I get that. So x times x gives me x squared. X times -4i is -4ix. 4i times x, positive 4ix. And then 4i times -4i is negative 16i squared. And then I don't know if you remember from your complex numbers, I squared equals negative 1. Okay, so from here we're going to simplify. So if I simplify this one, we can cancel these two middle terms. And then here we are substituting 16. I squared with negative 1. Okay. So that's why we have 16 times negative 1 is negative 16 times negative. Here goes that 16 that is down there. So plus 16. And then the next step is to multiply these two binomials. Okay, so here it is. So we have x times x squared, x cubed. X times 16, 16x. Negative 3 times x squared, negative 3x squared. And negative 3 times 16 is negative 48, which is down there. But this is negative 48. Okay. So then your polynomial here is negative 48. This is all of your polynomial. Okay. So this one is another example. So it says find the polynomial function f with real coefficients that has a given degree, zeros, and solution points. So this one says that the degree is 4. So that means that we have to have 4 zeros. And again, if you notice, they only give me 3. But they are giving me an I, which means that another one of my zeros is going to be negative I, because we need that complex conjugate here. And then they are also giving me something new, which is a solution point, and we're going to use that to find that a sub n that I had before. Okay. So first I'm going to list my zeros, which they are right here. Again, x equals negative I, because I need to write down the conjugate, the complex conjugate of I. And then these are my factors, and then we're going to multiply all of these. Okay. So this is the answer when we multiply everything, okay? And if you notice, it is to the 4th power because we have 4 zeros. The next step here is that we're going to use the solution point to find a of n, this part. Let me see if it looks better in another one. No. Okay, but this is what we have. So here, negative 8 is going to be f of x. So negative 8 equals an. And wherever we have an x, we're going to replace with 0. So I'm going to have 0 to the 4th power minus 3 times 0 to the 3rd power minus 3 times 0 to the 2nd power plus 3 times 0 minus 4. Okay. When I do all that, all these are going to cancel because they're times 0. So then I'm going to have left negative 8 equals an times negative 4. And then we solve for an. So we have negative 8 equals an, divide both sides by negative 4. So I have 2 equals a n. And then in the next slide is where everything is written down. Okay. So now we replace that an with positive 2. Okay, I'll go back there. And that's the last, that's the last slide. Do you guys have any questions? I know I'm sorry the PowerPoint looked like this.
Thank you, Ms. Fernandez, for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on a YouTube playlist. Today's session will also be available on the playlist later on today. Also linked is a short survey to help us improve our TVE sessions. Please take time to fill out the survey. Before you leave, I want to share the TVE sessions that we will have next. We'll be back with a Happy Math Hour next week, where both Math 1314 and Math 1324 will be covering the Exam 2 review for both courses. At 1 p.m. today, we will have Student Success topic, and today they will be covering the STEM Student Resource page. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or mic. We hope to see everyone again for Happy Math Hour. Have a great weekend, everyone.